two main factors that influence the reliability. And this is on the one hand side, the stitch sequence. So it depends on how and where we place the stitches, how many stitches we use. But we started our experiments with some PCB boards that were conventional, like the lily pad, or but then we were not satisfied with the reliability, just because we found out that these PCBs were actually not meant to be embroidered. So then we made another step, and we created a set of rules or recommendations for the PCB design, and we developed our so-called E-Tex board, which is a multi-purpose microcontroller board. And we use it mostly for fast prototyping for our customers, but also for our internal demonstrators. So yeah, we define this set of rules which are related to the hole size, the arrangement of the holes, and the PCB thickness, the PCB edge, which has to be filleted and metallized, and so on. So then we were able to increase the reliability of the embroidered connection significantly. And there is another way that the F-hat key helps us to improve this reliability. This is by covering the conductive pads with non-conductive thread. This can be done simply for decorative purposes, but it can also help for the mechanical protection, as it reduces the friction on the conductive thread coating. Or it can also be used for electrical insulation of the conductive pads, for example, to avoid the contact with the skin when it's not desired, or it can allow for two pads to cross each other. Then, once we figured out how we can integrate these PCBs, we wanted to automate the whole process. So together with Robert Bosch, we developed the so-called PCB placement device, which allows for the automatic placement, fixing, and connection of whole PCB boards. It can be like a single board or multiple PCBs in a single design. And there is no manual steps included into the production process. So this reduces significantly the production time, and because it's automated, also it ensures reproducibility, and this also increases the reliability of the products. And of course, mass production is also related to scalability, but this is a huge advantage of the embroidery technology, because basically it allows to really easily scale. So everything that can be produced on a single head machine can also be produced on a 10-head machine or a 32-head machine, for example, without the need of further development. Here you can see an example of a 6-head embroidery machine, which is used for E-Textiles, which we presented as a part of the Smart Textiles Microfactory at TechTextile 2019. And coming to the next technology, the K-head, these are the electrodes that I mentioned in the beginning. So you can see the three-dimensional structures, and yeah, we made this demonstrator to show that even from the face palms, there are very, very weak electrical signals that can be acquired with these electrodes, and it makes them perfect for ECG, EEG, EMG, or EMS or TENS applications. Then we come to the W head, which again enhances the automation because it allows for the automatic placement of wires, fibers, and tubes. And here you can see some applications, but the application area is actually very, very wide. And when it comes to decoration, home textiles, automotive interior, fashion, to like heating textiles for the medical field, or again for the automotive interior. So again, another example of the scalability. This is a 6-head W head machine, which is used in this case to mass produce